Hi, in this video we are going to talk about logarithms or logarithmic functions. So as a function, logarithms are the inverse of exponentials. For this equation being y equals 2 to the power of x, this is logarithms in base 2 of n equals x. What happens is that we can write this base and here the x as the power. This will give us a number which would be y in this case. So you can see this is the y equals x line, and this is the identity function, and according to that function, or based on that function, we can see that the exponential function is a reflection of the logarithmic function or vice versa. So this makes one as the inverse of the other. So when we have an index number, right, or an exponential, we call this as base and this as the power or index, right? Now, when it comes to logarithms, we write log in any base. We can say a, right, of any number, n would be x. So this is the base, right, and this is the index. Alright, now we are going to learn about the properties of logarithms because they are directly connected to index numbers. So the laws of indices sort of apply in here in a different notation. But first, let's talk about the meaning a little bit more. So if I have 3 squared, which is 9, I can write log in base 3 of 9 being 2. Now the relation is that the base and power goes on these spaces, right? So from here I can write this, and from here I can write this. So this is a circular connection between these two. Or another example, if I say 4 to the power of 3 is 64, then I can say log in base 4 of 64 is 3. So basically, I'm trying to define this number as a power of the base, and I'm trying to find what power of this base will give me this number. For example, if I was to write log 64, right, with the base 2, then I should be writing here 6, right, because 2 to the power of 6 equals 64. That is the relation. Or another example with 64, I can write 64 here, and I can write 2 here because I can choose the base to be 8. 8 squared is 64. So this is the relation between index numbers and logarithms, or in short, logs. So first of all, you must make sure that you can write one from the other. If you see this, you should be able to write this. Or if you see this, you should be able to write this. And the key is that logs in base a of any number equals x means a to the power of x, so a to the power of x equals n, this number, right? And vice versa. If you see these numbers, you should be writing the base here and the power as a result of logs, right? And this number should go here. So you have to be familiar with these conversions. Now, although we have calculators in use, we can just calculate, for example, log in base 3 of 81, right, without using a calculator. Now, the idea here is that we're going to use this identity. If the base and this number is the same, then you should end up with 1. Why? Because any number to the power of 1 is that number itself, right? So a to the power of 1 must give me a. So if the base and this number here is the same, then you end up with 1. How am I going to use that? Well, we have another property in use. We are going to write this as log base 3 of 3 to the power of 4. Now, I could choose to write log in base 3 of 9 squared, but I'm trying to get these numbers the same so that I can use this idea, right? So that's why I choose to write 3 to the power of 4. Then, this is equal to 4 times log in base 3 of 3. That's another property that we're going to talk about later. And just because this equals to 1, I will end up with 4 times 1 being 4. Alternatively, we can directly write 4 because we know 81 is nothing but 3 to the power of 4, right? So this is how we can write some basic logarithms without using any properties at all. When it comes to using our calculator, we will be using the log button here and ln button here sometimes, right? And there is also a log button here which allows you to write down the base as well. Now, when we write log base 3 of 81 into our calculator and hit equal sign, we end up with 4. So we will be using this button so that we can write down the base as well. When we don't need the base, or when the base is 10, right, at that time, I mean if it is 10, we don't write it, right? We can just skip writing 10 and we can say log, let's say 1000, all right? If I say or write log 1000, this means log in base 10 of 1000. So you should immediately figure out that the base is 10 if it doesn't write anything. And you should be able to write 3. And you can try it with this log button here, right? If you write log 1000, you will end up with 3, right? So if the base is different than 10, you should be using this button. If not, you can use this button here. Now, we also have the ln function. Now this in French is logarithme naturel, right? So this is my French, it's this much, sorry for that. But that's why we have the abbreviation ln. It's logarithme natural, so it's natural logarithm. Now, what makes a logarithm natural? So these natural logarithms are not free range or ecologically friendly or whatever. They just have the base being the exponential number itself, right? And then it equals to something. So basically, if the base of a logarithm is e, which is a number like pi, this is the first time you encounter with this, please write e in your calculator and calculate it. It is here. You can get it with pressing alpha and this button, right? This is also a number like pi. It goes up to infinity without any repetition, and it's not a solution to any algebraic equation, so it's a transcendental number, but it's a very special number like pi, and it appears a lot in maths. In P3 and P4, while differentiating, you will have a lot of e to the power of x while differentiating and integrating functions. Anyway, so if the base is e in log, then it's called as natural logarithm. This is how we write it down, right? So if the question says calculate log in base 4, 7, that's what you're going to do. You're going to use this button and write down the base and the number here so that you can calculate what it is. It's going to be a decimal number because 7, you can't get 7 by any integer power of 4, right? So it's going to be a decimal, hence the question will also give you the required rounding as well. It says 3 decimal places, 3 significant figures, whatever, right? So if the question asks you to calculate log 21, for example, you will just use this button. You don't need to enter any base because the base is 10, right? Again, you end up with a decimal and you write it down up to the required digit and round it, and so on. So log in base 4 of 7 is 1.403 up to 3 decimal places. This means 4 to the power of 1.403 will approximately be 7, whereas if we calculate log 21 with base 10, we'll get 1.322 again up to 3 decimal places, and this means 10 to the power of 1.322 is approximately 21. Well, it's an approximate value because we are rounding this power, the answer, right? So this is what they mean. So this is how we calculate it by using those buttons here. Thanks for watching.